Hello everyone, my name is Gufran and I will be talking about the Istio service mesh, and we will look into how we can use the Istio service mesh to secure our applications running inside the Kubernetes clusters, and we will look how we can implement authentication and authorization policies. So let's go ahead and get started. So this is the outline of the talk. First, we will start with the introduction to the Istio. We will look into the service identities, how we can use service account to convert it into the service identities that will be used by Istio. We will look into the authentication policies like TLS or MTLS, and then we will look into the authorization policies that will let us enforce access rules within our services, and then finally we will have some Q&A. So what do you mean by a service mesh? Service mesh is a infrastructure framework that handles communication between your services. For example, you want to have some kind of a network policies or retries or some splitting of the traffic based on the weightage and the latency. And of most of the times this service this is implemented as a network proxies, and that intercept the incoming traffic, and they are deployed along with your application code, and this is how they work. So you will have one container which contains the sidecar, which we call it as a sidecar proxy, and another container will be your application. So what does Istio offers? So Istio offers mainly the features. Istio features can be categorized across three categories. First is the security. Istio can help us to implement service-to-service communication, and we can implement access control within our services like authentication and authorization two rules. With the help of Istio, we can have complicated routing rules, retry, timeout, circuit breakers, etc. And this is more related to enhancing the resiliency of your services. It is more related to routing. And the third part is the observability with the help of service mesh. It offers rich metrics and traces of how your traffic is flowing within your service mesh, and which we can use for benchmarking or debugging the issues or any latency issues within our service mesh architecture. So important terminology. So when I say workload, what I mean is a pod or application deployed within your Kubernetes cluster. And when I say service, it is a microservice or an application that is going to serve some kind of a API or some feature to end user or maybe to another service. So this is how your pod looks like before we have the Istio. So you have two pods basically, or maybe one pod. Inside one pod you have your application logic, and then you have infrastructure logic like routing, circuit breaker code that will be deployed along with your business logic, or that is part of your application. And same goes with the container too. And this network policies are part of your business logic without Istio. And what we can do with the Istio is we can abstract your network policies, circuit breaker code, and routing or metrics related code inside a sidecar proxy, because Istio offers all these features to you. That is built into the Istio. We can leverage the Istio, and you can see now we have two containers. One container which only contains your business logic, and another container is a sidecar container that only contains your infrastructure logic or your network policies. And you can see now these two containers can be managed independently, and making a change inside your network policies will not require to roll out your business logic or your application code, and vice versa. So what the sidecar does? Sidecar is deployed along with your application part, and in general the name of your sidecar will be Istio proxy. And Istio proxy doesn't really modify your incoming request. It is transparent to the application code The only thing sidecar proxy does, it enforces your network policies to the incoming request, and if these network policies are not satisfied, it will drop the incoming request, and your container will not see, or your application will not see that request. And Istio uses the ny proxy as a sidecar proxy. It is written in C++. So how we inject the sidecar? So there are many ways to inject the sidecar proxy in your workloads. So one way is you deploy container, application container, and you also deploy sidecar container. That's manual way. Automatic, you can annotate the namespaces where you want to automatically inject the sidecar proxies like this, and it will, your Istio control plane will take care of injecting the sidecar whenever you deploy a new pod. And you can also add the annotations to your deployment and that will make sure it will automatically inject a sidecar proxy. So you have different way or different level of granularity how you want to inject the sidecar proxy in your application containers. And when, like, there are three part A, part B, part C, and as you can see, with each part there is a sidecar container which is Istio proxy deployed, and all the incoming and outgoing traffic is now being intercepted by the Istio sidecar proxy, and then it will forward the traffic to your actual container or your application. And so yeah, and this is the basic architecture of Istio sidecar. These are the different components of the Istio sidecar, Istio. And with the latest version of Istio 1.5, we have like all these components are consolidated inside the Istio control plane. And for example, Citadel is a part of it. It was a part of is control plane which used to generate the TLS certificate and deploy to or communicate it to the new parts or sidecar proxies. And there was a mixer which used to take care of the telemetry related data, and there was a galley that used to make sure your configurations are correct. But with the newer version of Istio control plane, all these services or all these components are consolidated inside the Istio control plane. Okay, so let's talk about Istio service mesh security. So when we talk about security, we will specifically look into the authentication and authorization policies. And when we talk about authentication and authorization, right, so we have to start from somewhere, like for example, service identities. Before we start enforcing authentication and authorization policies, we need to have some kind of identities assigned to each of our services inside our service mesh. And this will be the starting point. Once we have the established identities assigned to each of the service, then we can start implementing authorization and authentication policies. So there are different ways to implement or assign the identities to the services inside your service mesh. One of the very common ways using the service account. You can use the Kubernetes service account, and the service account basically becomes identity for your that application running inside the service account. You can either use the GCP service account or AWS IAM user role, or if you are deploying Kubernetes on-prem, you can use user account or some other account that you have. But in general, in most of the cases, you will be using the Kubernetes service account. So how we convert your identity or service account into a certificate that will become identity of your service. So whenever a new pod is deployed or a new pod is created, it will contain a sidecar container, Istio proxy, and your application. Okay, so your Istio proxy will create a public private key pair, and it will send a certificate signing request to the Istio control plane, and then control plane will sign that, create a certificate scoped within the service account, and send it back to the Istio proxy. Okay, and control plane takes care of rotating your SSL certificates whenever they are about to expire, and control plane serves your your SSL certificates through the SDS API, and your certificates are stored inside the memory. So if your container gets deleted, your certificate gets deleted basically. And this is how the workflow looks like. You create a new pod, your proxy sidecar Istio proxy will create a public private key pair, send it to the control plane. Control plane will generate generate a certificate, self-signed certificate, and then you can use that certificate as an identity for your service A. Okay, so by now we have some kind of a, so now we have enabled or established the identities for each of the service we are going to have in our Istio service mesh architecture. And now once we have the identities there, we can now start implementing the authentication and authorization policies. So Istio provides two types of authentication. One is the end user authentication, which you can use a JSON Web Token JWT, and we are more interested in the service to service authentication or MTLS. And there are multiple ways you can implement the authentication. One is the permissive, where your service mesh or applications or services running in your Kubernetes workload, they will accept the plain text traffic as well as the MTLS traffic. Okay. Second is the strict, where all the services will only accept the MTLS. Okay. And third is the disable, where we say, okay, we don't want any kind of the TLS encryption, we just want to go with the plain text communication between our applications or services. And this is how your MTLS looks like, or MTLS, how your request flow within your Kubernetes application. So on the left side we have workload A, in the middle we have workload B, and the right side we have the workload C. And client makes a request, and we can have a different policies, authentication policies for each of the workload. For example, you want to have MTLS for workload A, but workload B can accept plain text traffic and also MTLS, and workload C is only accept the MTLS again. So you can have different policies, authentication policies for each of your workload. And yeah, this is how your request flows within your service mesh. And this is how you can implement the authentication policies. There are different level of granularity you can implement the authentication. One way is like you implement the authentication all the service mesh wide, where all the services in your service mesh has to use the MTLS, and if they don't use, anyone try to communicate with your application and they don't use the MTLS, their request will be dropped. Another way is you want to enable the MTLS within a namespace. So any communication within that namespace will use the MTLS, and anyone try to communicate to the application inside that namespace, they will have to use the MTLS, otherwise their request will be dropped. Third way is you implement MTLS only for a specific service or a specific application. So there are multiple different level of granularity you can implement, but in general we want MTLS enabled within all of our service mesh applications, not just one namespace. We want it to be enabled for all of our applications inside our service mesh. So okay, so let's go ahead. I have a demo. We can look how authentication policies looks like or how it works in real world. Just with a quick demo. All right, so let's implement the authentication policies. And I have two applications deploy. I will be deploying two applications in two different namespaces. Okay, so I have a HTTP bin, which is a basic HTTP server. You can ping it and see it will respond with just status 200. Okay, so this is the deployment YAML looks like, and we are deploying it within some specific service account. Okay, and there is a sleep part that we will be using to make a request to the HTTP bin application. So there are two applications, one is the sleep, one is the HTTP bin, two different services, and we will try to make a request from sleep pod to the HTTP bin pod, and this is how my authentication policies looks like for the namespace foo. Okay, so HTTP bin will be deployed in the namespace foo, where I will deploy the sleep pod in a namespace bar, and foo namespace will have the MTLS, or it will have the sidecar proxy injected. This namespace is the part of your Istio service mesh, okay, and your sleep pod is not part of your Istio service mesh. It will not have any sidecar containers, okay, and anyone we will so first we will try without implementing the authentication policies, and then we will see how the communication works, and then we will implement the authentication policy, and we will see how it behaves, or how it automatically drops your traffic from sleep pod. Okay, so let's go ahead and deploy it. Okay, so I'll just go ahead, create namespace, and just deploy. So I will deploy it. Okay, all right, namespace is created, it's already there, and there is no change in the deployment YAML file, so everything is just up and running. Just check if everything is up and running. Okay, so you see HTTP bin has two containers. One is a sidecar, one is the HTTP bin container, and sleep pod. Like this is the sleep pod. This one it contains only one container. It doesn't have any sidecar proxies injected. These are two different applications deployed in two different namespaces. Okay, so now let's go ahead and let's see if we have some authentication policies or deployed or not. Okay, so we have one authentication policy which I was talking about. So let's see how your request will be dropped. Okay, so we have enabled the strict MTLS in our namespace foo. Anyone tries to communicate to the namespace foo, it has to do the MTLS, and our service sleep is not running inside a service mesh. It cannot perform the MTLS, and it will automatically reject our incoming request will be rejected by the HTTP bin or the sidecar proxy running along with the HTTP bin. Okay, so let's give it a try. Okay, let me do the asset inside the sleep pod. All right, I'm inside the sleep pod, and I try to access the HTTP bin where it only allows the MTLS traffic. So you see connection reset. So this connection is reset by the sidecar proxy running across with your HTTP bin container, because we have strict authorized authentication policies which says no communication is allowed without the MTLS. Okay, and let's go ahead, open a new terminal and delete the authentication policy which we deployed, and we will see how it behaves. Okay, okay. All right, so we deleted the authentication policies. Now as we see, we have deleted the authentication policies. By default, it will allow any kind of a traffic. So now what is expected is namespace foo should allow the traffic coming from MTLS or non-MTLS. Okay, so let's go back again to our sleep pod, and let's do the code again. And as you can see, we are able to communicate to the HTTP bin service, which is inside the service mesh, and sleep pod is not a part of service mesh. Okay, so this is how this authentication policies are deployed. You can either use namespace wide, or you can just enable it within all of your service mesh workloads, and you can have different kind of modes you want to enforce. Okay, so let's go back to the presentation again. All right, okay. So now we have implemented the secure communication within our services running inside the Kubernetes. Okay, we have enabled the TLS or MTLS encryption. All the communications within our services are secure. Okay, now whenever you are running some services inside your cluster, you may want to expose these services to the internet or some private endpoints, right? So this is where this Istio ingress gateway comes into the picture, and this Istio ingress gateway is kind of a entry point that serves as an entry point to any incoming traffic. All the incoming traffic goes to the ingress gateway, and from that ingress gateway it gets forwarded to the downstream services. And ingress, you can have different kind of ingress does the TLS encryption or TLS termination. You can say you can have a different kind of different rules how you want to route the traffic, how you want to manage the incoming request. And it is again it is just a reverse proxy running along with your ingress parts, and it will enforce all the rules that you want to implement or implement the routing. So there are different ways you can do you can manage the incoming traffic and how you want to do the TLS part of it. So there are three ways: pass through, simple, and mutual. And there are other more policies you can implement. But what pass through does is, whenever client making a request, it both the client and the application part has to do the MTLS. Pass through does not terminate your SSL certificate on the ingress gateway, but it passes as is to your application part, and then your application part will actually do the MTLS with the client. And this is how it works. It's more complicated one. There are more simple. Another policy is simple, which means you want to do the server side TLS. When I say server side TLS, it is just your client doesn't really need to provide a certificate. You will just create an ingress gateway. You will pass your service or SSL certificate to the ingress gateway, and whenever client try to communicate to your server, your client will just validate the SSL certificate of your server, and you can continue, and your TLS gets terminated. Your TLS termination happens on the ingress gateway. Okay, and there are mutual, the third policy, where client and the server, client or the ingress gateway, both this component will perform two-way MTLS, and your TLS termination will happen on the ingress gateway. Okay, so only pass through does only in case of only in case of pass through, your TLS termination doesn't happen on the ingress gateway. In other two policies, your TLS termination happens on the ingress gateway. And this is how you can define your ingress gateway, and we will go ahead and I will show you the demo. Okay, all right. So before I talk about or show you the ingress, I have the control plane, Istio control plane deployed, and I specifically want to talk about this one. Okay, so I have a different, there is one ingress gateway, there is one egress gateway, and Whenever you deploy control plane, you will deploy one ingress gateway that will give you some public or private IP address or DNS address, and that way you will use, or your client will use, whenever they want to communicate or want to access any of the services within your cluster through this ingress gateway. Okay, and there are more configurations. You can specify how you want to, like memory, HPA, availability, and all. We will not go into it. This is the name of your ingress gateway that we will use inside our ingress. Okay, so let's go ahead and see. So I have created the certificates, one for client, one for the Nginx pod, and this is what our deployment looks like. I will just deploy Nginx part that will contains the SSL certificate for the application or the Nginx server, and there is MTLS. I enable the MTLS bar within our namespace ingress. This is where our Nginx server is deployed, and this is the Nginx config where we are mounting the SSL. Like this is mounted as a config map and passed to the pod running. And this is what our ingress gateway looks like. So we are using the default ingress gateway that I just shown you just some time back, which is it will give you some IP address or public private IP address, and we are accept this gateway. Ingress gateway will accept the traffic only on port 443. We are doing, in this example, we are doing the pass through. The mode TLS termination mode is pass through, which means it will do the MTLS. Okay, but the TLS, like client will do its TLS, and TLS termination will not happen on the gateway, but it will happen on the application part. Like for example, the Nginx part, it will take care of the TLS termination part. You can have more configuration, like which kind of a minimum version you want to enforce, or some cipher suit, and host name. Okay, so incoming request should come from this host name. For example, you can add more host. So this is kind of a very critical part of your ingress gateway. You want to make sure you kind of specify or block anything else. We only enabling the traffic on port 443. We are doing TLS termination. We have some specific cipher suits. So this is where you have to be very careful or be very strict what you accept or what you don't accept. In this example, we are only accepting the traffic on 443. Anything else is not allowed, or any host name which does not match with this one, it will not be allowed. It will just drop the request on the ingress gateway itself. And then we are routing the incoming request. We are checking the SNI host, and we are routing it to the application running inside our ingress namespace here, and it is listening on port 443. So any incoming request will be routed to the Nginx pod. Okay, so let me go ahead So I have already deployed this, all of these things already configured, and if I go ahead and make a request here, okay, and this is my host name. I'm setting the host name incoming request. This is the port number. This is the public IP address of the Kubernetes cluster, and client is passing the client certificate, and we have the Nginx server which has its own certificates, and with this both the component will do the MTLS. So let me go ahead, and you can see we are able to access the Nginx pod. And if I modify it, okay, and I use the port 80, okay, it should not entertain this request. Okay, so you see it terminates, your request is terminated with some SSL error. Similarly, if your hostname does not match, Okay, for example, you just making a request from some another domain or host name, it should automatically reject the request, because in our gateway config we only accepting the traffic on from this host name. Okay, so this is where you configure or protect your incoming request, or this is your entry point, and this is how you protect your ingress through any other issues, or you can implement the termination policies and all. All right, let's go back. Okay, so we have, so far we have seen how we can implement the protect the traffic within our cluster, how to securely expose our application to the outside world, and the third part is we want to how by now any other application can try to access any other application, right? So for example, can service A can send request to service B? Yes, because we don't have any authorization policies implemented yet. So we want to make sure only required resources are allowed to access, right? For example, database, it can be accessed by backend, not the front end, right? So we want to implement or restrict the access to your services, right? Or we want to protect our services from any other services running inside our service mesh. And there are different ways. You can define the authorization policies where you can allow access or deny access to some applications or resources. And these requests are validated at the runtime by the Istio sidecar proxy. And if authorization policies are not satisfied, your request will be automatically dropped. Okay, for example, services try to access the service B, and authorization policy say service B cannot be accessed by any other service other than service C, right? So that request will be dropped. If service request is coming from service A, it will be dropped by service B. Okay, and in general what you want to do is you want to start your application, or you want to deploy your application, you want to set the authorization policies to deny all. That means your application cannot be accessed by any other application. And then you want to slowly open your application to other services, or your service to other services, right? For example, you deploy a database, you block all the access, and then you slowly open your application to another application like backend application, right? So it is how you can kind of go ahead when you implement the authorization policy. By default, deny all and then slowly open it for other applications. Okay, so this is how workflow looks like. Workload A, it has its own authorization policies. Workload B, it will have its own authorization policies. Whenever workload A try to access the workload B, authorization policies has to be met. If it doesn't match, you sidecar proxy will terminate your request. Okay, and these are validated at the runtime, and your control plane kind of pushes all of your authorization policies as you make changes there. And this is what authorization policy look like. I will just show the demo instead. Let's go back. This is the third and last demo. Okay. All right. Okay. So I'm deploying 3 applications. One is the SUS. Okay. One is the inventory, and one is the users. Okay. Let me go ahead. And we will just deploy this application in the same namespace for the simplicity, but whatever I say here is applicable to all of other, or if applications are deployed in another namespaces as well. I will explain what I mean when I say this. Okay, so we have 3 applications running: inventory, SUS, user, 3 different applications. Each application has the sidecar proxies injected, and okay, this is the authorization policies. Let's look at the authorization policies. So we are deploying this authorization policy inside the namespace auth, where our pods are running. These policies are applied to the SUS application, and what we say is application SUS can only be accessed by a namespace auth, which is running inside a service account inventory SA. Okay, so we are restricting right now only application running inside a namespace auth, and it is running inside a service account name SA. Okay, inventory SA, then it will allow the get request. So application this running inside this service account can make a get request to the SUS pod. Okay, and we have users authorization policies, and when I don't specify any rules, by default any request made to the user application will be dropped. You cannot access the user's application. Nobody can access it because there are no rules. By default it will just deny all. Okay, all right. Now let me go back and see if there is authorization policy. Okay, so it's already deployed. Okay, I have already deployed beforehand. We have SUSE writer authorization policy, which I explained, and there is one users authorization policies. Okay, and let's go ahead and go to the inventory part, and from the inventory part what we will do is like we will try to access both of these applications. Okay, go to the inventory part, try to access the users. Again, we have allowed the allowed access from user application, from inventory application to the user application, so it should work. Oh, sorry, so user is not accessible by anyone, so it should be denied by default. Inventory cannot access the users, right? But we have deployed the policies which says SUSE can be accessed by the inventory. Okay, let me go ahead. You see it is able to access the SUSE service or SUSE application. Okay, and if I try to make a post request, it should deny it, right? You see it's saying forbidden, right? Because inventory service can only make a get request and it has to satisfy this rule, right? And I will go ahead, I will delete right. So we deleted the authorization policies, and let's go back. Let me go just verify there are no authorization policies. See, no authorization policies. We go back to our inventory part, we make a post request. You see it is able to successfully access the make post request on the SUSE application. It can make the get request. You see, $200. Okay, and this is the part which is serving the request, right? And same goes for the users. There are no authorization policies. You should be able to make the users application as well from inventory, and you can also make post as well if you want. All right, so without authorization policies, it's open, anyone can access it. With authorization policies, you can restrict the access. All right, so with this we are done with the talk. Thanks for joining and have a nice rest of your day. Goodbye.